Although you may not have heard of the Doppler effect, you have surely heard the Doppler effect sometime. You will be wondering, where or how is this heard? Well, you can hear it whenever there is a sound source and a receiver, and one of these two is moving relative to the other. This is when something that produces sound is moving while doing so. After you watch the following video, I am sure you will understand what I'm talking about. Did you notice how as the fire truck approached, the sound of the siren seemed to be louder or with a higher pitch, and when it moved away it seemed to be weaker or with a lower pitch? This phenomenon is known as the Doppler effect. It received its name after the Austrian physicist Christian Andreas Doppler, who was the one who proposed in 1842 in his publication On the Color Light of Binary Stars and Some Other Stars of the Heavens the existence of this effect. It is said to be an effect because in reality the frequency with which the waves are emitted is the same, but the frequency that is perceived varies with the speed of movement of the transmitter or receiver. For example, if an ambulance approaches you at 120 km per hour and emits 10 sound waves every second, which travel at the speed of sound, that is approximately 1200 km per hour at sea level, you will be listening to 11 waves per second, since the speed at which the ambulance moves makes the separation of the emitted waves less, and it might seem that more waves are being emitted. Something very interesting is that the Doppler effect not only applies to sound, it can also be perceived in light. The light, also being an electromagnetic wave, must have a frequency. This is a number of cycles per second, that is the number of times a wave is repeated in 1 second. This repetition is measured in hertz. In the case of light waves, the lowest frequency are red and the highest frequency are violet ones. To an object that moves away at a high speed, and I mean speeds of thousands of kilometers per hour, will tend to look redder than it really is because the Doppler effect will make the waves more separated, that is, a lower frequency will be perceived. On the contrary, if an object is approaching at very high speeds, the light waves it emits will be closer to each other than usual, which will make it look blue or violet. The red color is around 480 terahertz, while the violet color is around 750 terahertz. Perhaps no example comes to your mind right now about how this could affect us or how we could prove it, but there is. Between 1922 and 1927, scientists Alexander Friedmann of Russian origin and Belgian priest and scientist Georges Lemaitre used Einstein's theory of relativity to prove that the universe was in constant motion. A short time later, not the telescope, Edwin Hubble, the astronomer, will discover several galaxies beyond the Milky Way, which he presumed were constantly moving away from us. But you might wonder, how did he know that they were moving away? Was the movement perceived in his telescope observations? Well, no. It was not a perceptible displacement, but he made a theory in which he demonstrated that movement in a scientific and measurable way. Stars emit a characteristic color depending mainly on their temperature and atmospheric composition. It is possible to know which elements make up the atmosphere since each element absorbs certain frequency ranges of visible light. Those ranges are always the same, whether it is one star or another, and they are known as Fraunhofer lines. In his observations, Hubble noted that the lines coming from these galaxies were out of phase towards the red side of the visible light spectrum. This is, we perceived less waves per second than those emitted, which combined with the Doppler theory allowed us to demonstrate mathematically that all the stars that we can observe are moving away at a constant speed from us, known as the Hubble Constant. From this idea, the Russian scientist who would later become American, George Gamow, raised an idea in which he explained that since everything we observe is constantly moving away from us, there must have been a historical moment in which all the matter was concentrated in a single point and that a trigger caused it to start moving at the same constant speed in all directions. That is what we know as the Big Bang Theory. This is how the discovery of this phenomenon, the Doppler effect, has allowed us to have what is probably the most important theory to understand the origin of our history as a planet, solar system, galaxy, and universe. But as some of you may have noticed, much of our life is spent without leaving the planet. So we have found applications for this effect in more earthly situations. One of the first examples we have occurred during the Second World War. The Scottish engineer Watson Watt proposed to the government of England to create a system of antennas capable of detecting enemy airplanes before they could see them. This system would consist of a set of antennas that would emit a signal in all directions. This signal or radio wave would travel through the air until something got in its way. When hitting an object, the waves were reflected in the opposite direction and the ground antennas received it. Through the principles of Doppler, one could measure the distance at which the enemy aircraft were located as well as their position, and when comparing two radar images obtained in a given time, their speed could also be known. Without any doubt, this is one of the inventions that helped the Allies win the war. But since not all of us are the United States, we are not always at war. So, other known war uses have been found as well. The first of these was evidently to continue using radars in aviation but for commercial purposes. These allow air traffic controllers to maintain the necessary separations between all aircraft. Another type of radar that was invented was the weather radar, that works on the same principle, but instead of impacting against the fuselage of an airplane, the waves impact the drops of water inside the clouds, which generate an echo and let you know the position and storm intensities. In medicine, it is used to make images of great precision and detail known as tomographies or magnetic resonance imaging. It is also used to measure blood flows. But not everything could be so good. I can think of one use of the Doppler effect that is not liked by many of us, and these are the speed cameras. So now you know who to thank the next time you find in your mailbox a speeding ticket. I find it amazing to see how many applications a single theory has had. So when you hear the sound of an ambulance again, remember Doppler and the curiosity he had to explain the world around him. Today I leave you with the following quote from Albert Einstein. The important thing is not to stop questioning. Curiosity has its own reason for existence. One cannot help but be in awe when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries to merely comprehend a little of this mystery each day. Thanks for watching this video, and please help us by subscribing to the channel and sharing our videos with your friends. See you the next time.